Good morning, student. Let's start today's class. In today's class, we are going to discuss about the components of a wind power plant. Okay, so a wind energy generator, okay, or wind power plant consists of the number of components there, um, and in today's class we are going to discuss these components one by one. Okay, the first component is wind turbine. Okay, the first component is wind turbine. Okay, there are various type of rotor depending upon the number of blades. Okay, speed, control system, okay, gearbox, type of generator, okay, etc. All the mechanism are based on the basic four concept of the rotor dynamics. Okay, they are given in the table 11.2. Okay. All the rotors, okay, all the all the turbine rotors, okay, all types of turbine rotors are based on the uh, four principle. These four principle, okay. First one is lift principle, horizontal axis. Okay, then what is the lift principle, horizontal axis? High speed system, one blade, two blade or three blade rotor. Low speed system, historically windmill and multiple rotor and filtered rotor, cell rotor. Okay, this is the that means this is the one. That means this leaped principle, this is the four principle, uh, and based on the leaped principle, this is the classification of the rotor. Okay, the first one is high speed system, second one blade, two blade or three blade. Okay, then low speed system, what is historical windmill. Okay, multiple rotor and filter water rotor and cell rotor. Okay, similarly, lift principle, vertical axis. Okay, this is the principle, and this is the high this is the type of rotors. Okay, the high speed system, okay, Darius rotor, H rotor, three blade rotor, okay, low blade, etc. Okay, similarly concentrating windmill, also different type of rotors. Okay, drag principle, also different type of rotors. Okay, now you see, uh, this is after extensive field experience. Horizontal axis three blade wind rotor has become an established system for field application. Okay, so the horizontal axis three blade, okay, with rotor, this type of rotor is used extensively, okay, for the field application. Okay, in 1980 and 1990, one and two blade rotor were also developed because of higher rotation speed, but due to instability experienced during operation, these were not continued further. Okay, in modern fast wind machine, essentially two type have been developed for power generation in many part of the world. Okay, in figure 11.27 shows both the wind mechanism with a gearbox and without gearbox. The advantages of using a gear is to rotor is flexibility of using a standard generator. A gearless rotor requires a special generator that should be able to operate at a great generated number of rotation. Okay, it it can be observed from that the first of all, you see, 11.27, this is okay, 11.27, this is two types of rotor. Okay, one is gearless, this is gearless. Okay, this is gear rotor. Okay, with gear rotor. Okay, now uh, this is this is gearless, and this is a gear with gear. Okay, gearbox. Now you see here, you see the extra components here. the extra components where the generator is connected. Okay, and when this is a gearbox with gearbox, so that the general generator is can be connected with the rotor. Okay, but in gearless, a special type generator can be connected in for matching the rotation speed. Okay, now see figure 11.27, okay, shows both the wind mechanism with a gearbox and a gear without gear. Okay, the advantages of using a gear in a rotor is a flexibility use of okay. Then figure 11.27, that the power is maximum for the particular number of rotation and for a particular wind speed. Okay, higher rotation yield higher power. Okay, that suit common generator. Okay, the rotation are usually between 1000 rpm to 1500 rpm. Okay, gearless rotor are low speed converters require a special generator. Okay, gearless rotor are low speed converter. Okay, so that it require a special type of generator which generate require amount of power in the low speed. Okay, now you see the figure the figure this figure 11.26 and 11.1. Okay, shows that there are a optimal number of rotation, okay, for every wind speed at his maximum rotor power is achieved. Okay, figure is also illustrate that power coefficient of an wind turbine is maximum for a particular value of tip speed ratio ensuring higher power extraction. Okay, and optimum number of blades is 3, and a blade, remember this optimum number of blades is 3. Okay, and the blade design is narrow shaped. Okay, you see in wind turbine you see there are three blade wind turbine. Nowadays there are three blade used. Okay, and you see the blade shape is very long. Okay, the blade length is very long, and the blade is narrower in the tip. Okay, like that the blade is this is the efficient blade design. Okay, narrower towards the tip. Okay, now the blade 3 and blade design is narrow shaped. Okay, optimum tri speed ratio. Okay, for a tri blade rotor, tri blade means for a 3 blade rotor is between 6 to 10. Okay, this optimum tip speed ratio, okay, is 3 to 6 to 10. Okay, the corresponding generated noise is also low. Okay, here the corresponding generation noise is low. The power extracted from a wind rotor is proportional to the rotor area. Okay, higher the capacity of the wind generator, larger is the area of the rotor. Okay, rotor area, that means this area. Okay, this area, when this area is large, then it can generate high power. Okay, or when this area is small, that it can generate low power. Okay, then beside rotor blade, other major component of a wind generator are the hub essential, nacelles, main shaft, and power conditioning equipment. Okay, the rotor hub connected to the generator and other mechanical and electrical system. Okay, that here you see this is the tower. Okay, this is the foundation. Okay, and this is the grid. Okay, and this is the blade. Then this is the nacelle bearing. Okay, this is the nacelle bearing, and this is the electrical switchboard for control system. Okay, then disc brake is there. Okay, and a rotor turning ring. Okay, then standing rotor blade adjust devices. So many components are there. Okay, here in gearbox, this is without gearbox, and here is their gearbox is there. Okay, rotor brake as there. Okay, anemometer, this is an anemometer. Okay, then generator is there. Okay, nacelle bearing is there. Okay, so many components are there with the rotor blade. Okay, now you see the nacelle of a wind machine. Okay, is the house that contain various other important components like generator, clutch, gearbox, bearing, brake, generator, control mechanism, etc. Okay, this nacelle box or nacelle part of the wind machine containing this component. Okay, then the transmission of power from the rotor to the generator is performed through transmission system, which consists of a gearbox or a chain drive to match the rotation speed to the desired speed of the generator. Okay, so this is let's say this is the rotor. Okay, this is the shaft. Okay, this is the rotor, this is the shaft. With gearbox, there is a gearbox and it connected, or the transmission is connected to the generator. Okay, this is generator, then this is gearbox. Okay, now without gearbox, this transmission line or the shaft of the rotor is connected with chain to a generator. Okay, to a generator. Okay, to match the speed of the generator. Okay, now in a gearless mechanism, the generator is a permanent magnet multipole equipment that very different than the conventional generation. Okay, generator. Okay, now the material used for fabrication of rotor blade is normally glass fiber. Okay, remember this. Reinforced plastic recently. Okay, reinforced plastic recently there is a tendency to use coal and aramide fiber. Okay, the the predominant criterion is the figure strength along with the specific weight, administration stress, and not only remember this, the material used for fabrication rotor blade is normally glass fiber plastic. Okay, now there are four mechanisms for adjusting the rotor blade, namely the rotor bearing. Okay, blade adjustment drive, energy supply, and emergency adjustment system. There are four systems. Okay, now rotor blade bearing is normally hinged to the rotor blade near to the root of the hub. Okay, now normally one use the turbine. Okay, or moment bearing. Okay, some blade design allow the adjustment of tip only. Okay, in this case the bearing is located in the outer section of the blade. Okay, now similarly rotor blade may be adjusted electromechanically or hydraulically. Okay, by hydraulic system. Okay, then centering, then shortening. Now let us see the tower. Okay, the tower means this tower. Okay, tower, a component that carry the whole weight of the rotor and the nacelle of the wind machine is the tower. The tower should be sufficient height to be able to operate at the desired wind speed. Okay, tower should uh, also be able to sustain various static and dynamic loads that are expected on it by the rotor and nacelle due to high and gusty wind. The the tower has to sustain mechanical vibration and resist weather and material fatigue. Material also be fabricated. Material used to fabricate a machine tower is either concrete or steel tower are either in lattice form or a tubular structure of conical structure. Okay, design. Okay, conical steel design is most common for higher power capacity wind mechanism. Concrete tower of conical design are favorable because the increase tower height. Okay, offshore wind mechanism machine tower are of lower height because of higher wind speed. Okay, however, the foundation of offshore mechanism is much more costly. Okay, so in the next class we will see the electrical generator. Okay, thank you.